use overall approach for human interaction for robotic navigation challenge on student dataset. Our pipeline can be divided into two parts: a navigation model as shown in the left, and a reference model that points out the target object in the panoramic view. The motivation is that we find that simply use an end-to-end navigation and detection model will result in an insufficient training in detection head. Since the detection head will be only trained in the correct endpoint in each episode, so it will be insufficient. So here we adopt the baseline model named graphic-based exploration from the original paper of student dataset as our navigation model, and TransVG model as our reference model. And we train them separately and combine them together in the inference stage. We also use a distance-aware strategy to make the navigator aware of the distance of the next step. For instance, in some scenario, the model predicts higher losses for point f1 than point f2. However, it also has a longer path for point f1. So we take the distance as a normalizer for the losses and make the model tend to choose point f2 instead of f1. So in other words, we make a trade-off between the path length and the success rate of the navigator. After adjusting the hyperparameter W, the navigator will tend to choose some shorter paths with a comparable success rate. Besides, we also fine-tune some other hyperparameters like the maximal step to make the model achieve higher SPL. As for the reference model, we slightly modify the original version of TransVG to make it adaptable to the student tasks. The student tasks requires to output the heading and elevation of the target from the panoramic view. We alter the output to regress the target heading and elevation. We also add the orientation embedding of each viewpoint in the visual branch. Besides, there are also some other tricks. We adopt the pre-trained DTR and board weight for the visual and the linguistic branch. We also separate the target heading and elevation into several bins and predict its offset within the bins for more accurate prediction. In the end, we also perform the model ensemble strategy. Our result shows the efficiency of our method. The distance-aware strategy slightly lower down the path length with the comparable navigation success rate, and the additional reference model TransVG lead to a better final detection success rate. Here are some references for this presentation, and thank you for watching. That's all.